are to find a polynomial of degree 4 that has integer coefficients and zeros of 7, -7, 8, and 1/2. We know that when a polynomial has a zero of, say, c, then x minus c is a factor of that polynomial. So we will have a factor of x minus 7. We'll have a factor of x minus a -7, which is x plus 7. We'll have a factor of x minus 8. And we'll have a factor of x minus 1/2. Now, that factor of x minus 1/2 is going to be troublesome because we're told we need to have integer coefficients. So we know that if we multiply by a constant in a polynomial, the effect of that does not change where the x-intercepts or the zeros are. It simply stretches or shrinks the graph of the polynomial vertically. And so what we're going to do is we're going to multiply this factor of x minus 1/2 by the smallest integer, actually the denominator of the fraction that we see, the smallest integer that will give us a product which has integer coefficients. So we're going to multiply it by 2. When we do that, we're going to get a new factor of 2x minus 1. We're going to use the factor 2x minus 1 and multiply that with the other factors to give us our polynomial with the smallest possible integer coefficients. Multiples of 2 would also give us integer coefficients. So our polynomial is going to be x minus 7 times x plus 7 times x minus 8 times 2x minus 1. So this gives us x squared minus 49 when we multiply the first two binomials together. Gives us 2x squared minus x minus 16x plus 8 when we multiply the last two binomials together. So x squared minus 49 times 2x squared minus 17x plus 8. We're going to get 6 terms when we distribute the x squared and the -49 over the trinomial. We're going to get 2x to the 4th minus 17x cubed plus 8x squared plus negative 98x squared plus 833 x minus 392. So we've got 1 x to the 4th term. That's so 2x to the 4th. We've got 1 x cubed term, negative 17x cubed. We have 2 x squared terms, 8x squared minus 98x squared. So that's going to give us minus 90x squared. Then we have plus 833x minus 392. And this will actually be the polynomial with smallest integer coefficients and the given zeros. The second example starts with a given graph, and here we're to find the third degree polynomial whose graph is shown. Now we have to take into consideration not only the zeros, but also the y-intercept, because of the fact that multiplying by constant stretches or shrinks a polynomial vertically but does not change its zeros. There's actually an infinite number of polynomials that have a given set of zeros if you take into account the fact that you could multiply by any constant. So in this case, we have a third degree polynomial. The graph crosses the axis at x equals negative 2, so that's going to be a zero of multiplicity 1, but is tangent to the x-axis at x equals 1. So we know there's even multiplicity at x equals 1. It will have to be multiplicity 2 because we've only got a third degree polynomial. So our zeros, I will double count the 1 to remember that we're going to have two factors of x minus 1. The y-intercept this time is at 0, 6. So crosses the y-axis at 6. So as we're building our polynomial, we know that it's going to have a factor of x minus a negative 2, which is going to be x plus 2, and two factors of x minus 1. And that there's going to be some possibly other constant in the product. So we know that since the y-intercept is 6, that the function evaluated at 0 has to be 6. So let's substitute 0 for x to get p of 0 equals c times 0 plus 2 is 2, 0 minus 1 is negative 1, 0 minus 1 is negative 1. So on the right-hand side, we get 2c. On the left-hand side, p of 0 is 6. Dividing both sides by 2, we get that c has to equal 3. And so p of x is actually equal to 3 times x plus 2 times x minus 1 squared, which is x squared minus 2x plus 1. So multiplying x plus 2 by 3, we get 3x plus 6. You'll get 6 terms when we expand this product. We'll get 3x cubed minus 6x squared plus 3x plus, now add multiplying by 6, 6x squared minus 12x plus 6. When we combine the like terms, we get 3x cubed minus 9x plus 6. The x squared terms neutralize each other.